This is the Engines of Our Ingenuity, made possible by the Friends of KUHF, Houston.
Today, the old question about theory and experiment comes back to haunt us. The University of Houston's College of Engineering presents this series about the machines that make our civilization run and the people whose ingenuity created them. Scientists and science-based engineers talk about theory and experiment as though they were separate things, but they are not, and that causes all kinds of trouble in our writings. Now, in the face of computers, the matter grows hopelessly confusing. The essential question facing any scientist is how to learn the nature of things. The medieval model was to make deductions based on a minimum number of facts. If nature obeys a certain logic, don't we need to follow that logic to understand nature? Our vision swung outward in the Renaissance. We learned to learn by observing nature more than by reasoning with her. That led to the creation of wholly new sciences based on observation, anatomy, geography, botany. So the essential tension in science became the tension between deduction and observation. We've adopted a shorthand for that tension. We call it theory versus experiment, but there's a catch. Every great thinker has combined the two: Galileo, Newton, Einstein, G.I. Taylor. Every worthwhile insight comes to rest on both inner and outer vision. So where does math fit in this process? Math is the language of deduction. It exists apart from the facts it deals with, and it's important in either kind of thinking. You can conjecture reality and then see where the logic of math takes it, or you can observe facts and see how math links them. Now, back to that word theory. A theory is a conjecture that's been proved. It might be the stuff of mental invention, but it can't lose sight of experience, or the synthetic experience we call experiment. Theory and experiment cannot be separated. Now computers let us combine existing models of reality with deductive processes. Computers can actually tell us the outcome of experiments, at least according to existing knowledge. That can be so seductive that we forget what Lord Byron's daughter Ada wrote about the computer way back in 1843. She said, "It can do whatever we know how to order it to do. It can follow analysis, but it has no power of anticipating any truths. Its province is to assist us in making available what we're already acquainted with." Today's science literature has shifted dramatically toward computer-generated realities, and while they may extend our knowledge, they can never replace true theory and experiment. They remain rooted in what we knew when we began. Ada was right. They can only make available what we're already acquainted with. Within the exponentially expanding engineering literature, the fraction of true experimental papers is shrinking away. What's less obvious is that experiment and theory die together. And as they do, the problem spills over into education itself, and it reaches down all the way to our increasingly computer-driven grade schools. I'm John Lienhardt at the University of Houston, where we are interested in the way inventive minds work.